Here we go. This is exercises 25-3. This is number 1. Okay, so we have a random sample. Okay, a random sample. So we don't have 2 samples. Okay, so on the AP test, you're going to have to figure out, well, what test am I going to use, right? And so make sure you see that we have a sample, and then we got some categories here. And so it's asking for some data, categorical data. Did you use the internet yesterday? And then are you white, black, Hispanic, other? Is there evidence that the internet usage and race are related? Okay, so related means not independent, right? So it could ask, and we got to be a little careful if it does ask this. It says, it could say, is there evidence that internet usage and race are independent? So that's a little bit different question. We got to be careful with that because the null hypothesis is going to be that they are not related. Let's take a look at the null and the alternate hypothesis. Internet usage and race are not related. Okay, so not related, that means independent. Now, if it does say independent, remember, we never want to accept the null, right? So we got to be careful with how we word our conclusion at the end. Remember, alternate hypothesis, that's what we're looking for evidence of. Alternate hypothesis is what we're looking for evidence of, okay? So is there evidence that internet usage and race are related? So that's what our alternate hypothesis is. So just keep in mind that not related means independent. Are related means not independent. So we're looking for evidence that supports that internet usage and race are not dependent, or maybe we don't have evidence of that. Okay, all right, so let's move on. All right, so the next thing we're going to check is conditions. So we got a random sample, it says that in the problem. And then here we go. Sometimes we put this, sometimes I like putting this in 2 bullet points, but it doesn't really matter. The data are in counts, that's 1, and are independent groups. Okay, so that's important. Data are in counts and independent groups. The expected values are all greater than or equal to 5, which we don't have yet. That's why it says as displayed in the table below, and we're going to get that. We'll get that in a moment. We need our expected values, and here's what you got to know. You got to know that your expected value is row total times column total divided by the grand total. So we're going to take a look at our given table, and we're going to grab our calculator, and we start adding. Okay, we'll find some totals. Okay, let's find some totals. Here we go. And there we are. Okay, so there's the totals. I added those up. And now we're going to use this formula here that we got to find the expected value. We're going to put the expected values in a table. And there's our table, okay? We have the expected value. So take a moment to check, make sure you know how we're getting those. Row total times column total divided by grand total. The grand total being 4,467, of course, there. Okay? All right, here we go. So the next thing that we're going to do is we're going to kind of finish the conditions section by calling out the test that we're going to use. It is important that somewhere that we do have degrees of freedom too. We have to make sure we say that. Okay, and so I will use a chi-square test for independence with degrees of freedom 2. Okay, because remember that's usually what we call it. Actually, a chi-square test for independence. That's what our book calls it anyway. Here we go. And for the mechanics, make sure that you that you're showing how you're getting your chi-squared statistic and how you're using that to find your p-value. And then you can compare that to a reasonable alpha level of 0.05 and then go to town. Here we go. So we remember that the mechanics, chi-squared, there's our formula. It's a good idea to have that written down. And boom. Oh, this right here, this blue one, I believe that's in your packet. So just make sure you're familiar with everything that's in your packet, because if you're on the test, you don't be like, oh, I can't remember that formula, and then you just had to turn the page, right? So here we go. So let's take a look. So this symbol right here, the sigma, that's summation. So we're adding up all these. So that's how we find the chi-squared statistic. And there's 1, 2, 3, 4, 5, 6 things to find there. There's 6 things to find. And once we have the chi-squared statistic, 11.35, it's a good idea to have a little diagram just to make sure everything is in there. Because now you have to show how you're using that chi-squared statistic to find your p-value, because you're going to use your p-value to get a conclusion. So it's pretty important that you show how to find your p-value. Degrees of freedom is pretty important as well. So let's degrees freedom equals. All right. So there are two columns, yes and no, right? So we're going to multiply 2 minus 1 by the number of rows. We have 3. So we're going to multiply 2 minus 1 times 3 minus 1. That's how we get the degrees of freedom too. So make sure that's in your work somewhere. You got to have that. Okay, degrees of freedom 2. So our p-value we get by doing the probability that our chi-squared statistic is greater than 11.35, right? That's the p-value here in our little picture. All right, and so we're going to use chi-square CDF for that. Okay, chi-square CDF in our calculator. Make sure if you're not getting that, if you don't know what to do there, email me, let me know, and I'll help you out. Okay, so remember mechanics. It's a good idea to have the formula. Then you're going to show all this work, right? Show all this to make sure you get points for that. Make sure you have all the values put in. Make sure you put observed minus expected squared over expected value. So make sure that all works there. Make sure you have a nice, neat little diagram with everything written in and how you're finding the p. Okay, so how you find the chi-squared statistic, and using that to find the p-value. That's important. Okay, so now let's take a look at our conclusion. Since our p-value of 0.003, so we're calling out p-value, and we're very clear that we're comparing p-value with an alpha level, okay? So we use the words less than or greater than, right? So here we go. Since the p-value of 0.003 is less than an alpha level of 0.05, we will reject the null. Now make sure you know what that means. That means there is evidence of the alternative hypothesis. So make sure that you look at how you worded your alternate hypothesis. There is evidence that internet usage and race are related. There we could stop and just put a period there. I like putting not independent, especially if the question actually asks about dependence. So we got to be careful with that, how you word that. But there we go. If you have any questions, please ask. Okay, hang in there, work hard, and I'll see you later.